Today we're going to work on how to use the converse of the Pythagorean theorem. So if you remember, a converse is when what you started with in the original theorem you then finish with. And the Pythagorean theorem starts with if a right triangle. So it starts with the words if a right triangle. So that means that the converse of that is going to end with right triangle, meaning if we have a certain set of conditions, then the triangle is a right triangle. In 7.1, you might have noticed that every triangle, so I'll draw this, every triangle that we had, somewhere had a right angle symbol on it, so that we knew that we were dealing with a right triangle. What we did with the Pythagorean theorem. So we can see that there is a right angle symbol there. So basically 2 squared plus 5 squared is going to equal x squared. 2 squared is 4. 5 squared is 25 equals x squared. So 4 plus 25 is 29 equals x squared. So square root of 29 is going to equal x. Okay, next problem. Catch myself, I said yesterday we should start using the c squared equals a squared plus b squared. Now for here, they want us to simplify this. 5 squared is 25. Radical 3 times radical 3 is 3. So 25 times 3 is 75. And on this problem, they want us to find the side length. So x squared, actually I'm going to change that, because I actually want to do c squared. So 15 squared equals x squared plus 12 squared. 225 equals x squared plus 144. If I subtract 144 from both sides, 225 minus 144 is 81. So if 81 equals x squared, x equals 9. Now, some of you may be yelling at home, oh wait, you could have done this with a Pythagorean triple. And you can if you've memorized your Pythagorean triples. So I can see that 12 and 15 are both divisible by 3. So this would be 4, this would be 5. And if I remember from my chart, 3, 4, and 5 are Pythagorean triples. So if 15 is gotten by taking 5 times 3, then 3 times 3 is 9, and the answer will be 9. The converse of the Pythagorean theorem is also true. As I said, the theorem says if a triangle is a right triangle, so the converse is going to end with, then it is a right triangle. If the square of the length of the longest side is equal to the sum of the squares of the other two sides, then the triangle is a right triangle. And we point out that we're not calling this the hypotenuse here because it's only, the longest side is only has that special name of hypotenuse if it is in a right triangle. Since we don't know yet if this is a right triangle, we're just going to say the longest side. And you can go through these problems to say whether or not the triangle with these given side lengths is a right triangle. So for instance, 4 squared is 16. 4 times 4 times 3. So 16 times 3 is 48. So 4 plus 48, if that equals 64, then it is a right triangle. 10, 11, and 14. That's 100 plus 121 equals 14 times 14 equals 1, does not equal 196. So it's not a right triangle. Now, as I said before, I really should be writing the c squared on the left-hand side. And I'm going to show you why in a minute. Last one. 5 squared is 25. 6 squared is 36. Square root of 61 is 61. Square root of 61 squared is 61. 25 plus 36 is 61. That is equal. So that is a right triangle, as we said. Number 2 is not a right triangle. So the question is, what is number 2? And we can use Theorem 7.3 and 7.4 to help us. Went through these in class, but basically, if the square of the length of the longest side of a triangle is less than the sum of the squares of the two lengths of the other two sides, the triangle is acute. If the sum of the length, if the square, of the length of the longest side is greater, then it's obtuse. So using this information, we can look back here. We can see that 196 would actually be less than 221. And less than tells us that it is an acute triangle. And that's why setting these up where the hypotenuse, or the longest side, the c squared, is on the left-hand side, will make it just a tad bit easier, or a whole lot easier. Show that the segments with lengths 3, 4, and 6 can form a triangle. So since 3 plus 4 is greater than 6, it can be a triangle. And now let's see what type of triangle it is. So my longest side is 6. 36 is 6 squared. 9 is 3 squared. Plus 16 is 4 squared. 36 equals 9 plus 16 is 25. So 36 is actually greater than 25, which means it is obtuse. And that's the work there to show that it can be a triangle, and that triangle is obtuse. What if, in example 3, you could use triangles with side lengths 2, 3, and 4? If you need to, here's a good concept summary chart that you can go back through and take notes and use to keep Theorem 7.2, 7.3, and 7.4 straight in your mind. We can do two ways. We can first do as a Pythagorean triple if we realize that all of these are divisible by 3. 24 divided by 3 is 8. 45 divided by 3 is 15. And 51 divided by 3 is 17. Since that's a Pythagorean triple, I know that it's a right triangle. But let's say I didn't memorize my Pythagorean triples. I could say 24 squared plus 45 squared. Does that equal 51 squared? So 51 squared is 2,601. 24 squared is 576, and 45 squared is 2075. Sorry, 2025. 2025 plus 576 is 2,601. It's equal to 2,601. Since those are equal, yes, it is a right triangle. Tell whether the segment lengths can form a triangle. If so, tell whether the triangle is acute, right, or obtuse. So just for approximation here, square root of 17 times 3 is that number. So 7 plus 11 is greater than that. We can have a triangle here. So 3 squared is 9 times 17 is 153. That is 3 times radical 17 squared equals, or we don't know what. 11 squared is 121. 7 squared is 49. 49 plus 121 is 170. Since 153 is less than 170, it's acute. For the next problem, 9.2, 4.1 plus 5.6 is greater than 9.2, so this can be a triangle. 9.2 squared is 84.64. 4.1 squared is 16.81. 5.6 squared, whatever that is, when I add those together, I know that 84.64 is going to be greater. So I know that the answer has to be obtuse. A playground has a slide, a swing, and a sandbox. You can read through the problem. They are set up like a right triangle. Like a triangle. We need to determine if it is a right triangle. Yes, if you know your Pythagorean triples, you can use your Pythagorean triples to solve this. But I'm going to do 50 squared equals 48 squared plus 32 squared. 48 squared is 2,304. 32 squared is 1,024. That plus that is 3,328. I just want to double check my math. Okay. And 50 squared. So the answer is no. The three pieces are not in the form of a right triangle. Here are the problems that you can look through. And thank you for watching.